Hello everyone. In this video, let's discuss about the operators in Java. So first, let's discuss about arithmetic operators. Okay, fine. I'll start with importing the package. Import java.util.start class main. The execution of the program always starts from the main method. Public static void main string args. The string args is called as command line arguments. Fine. Now I'm going to declare two variables, int a equal to 12, b equal to 5. So I have taken two variables. So when we talk about arithmetic operators, we have addition, subtraction, multiplication and division. And when we go for division, we have two different types of operators. One is modulo operator and another is division operator. That we'll discuss in detail. So here directly I'll print all the values. System.out.println. I'll give a plus b. So when I give a plus b, it adds these two values and gives the output value as 17. So I'm commenting the output. So 17 is the output. Similarly, when I go for subtraction a minus b. So here I'll have the value as 12 minus 5, which is 7. Then I'll go for multiplication. System.out.println a into b. This we call this multiplication operator. We'll get the output value as 60. 12 into 5, 60. System.out.println. As I mentioned earlier, division we have two operators. One is division, another one is modulus. So a divided b, it gives me the quotient value. So 12 divided by 5, I have the quotient value as 2. So 2 will be the output. System.out.println modulo operator, a modulus b, it gives me the remainder. So when 12 is divided by 5, the remainder value is 2 and quotient value is also 2. So I'll have the output value as 2. That's all. Let me run the code now. See, I've got the output value as 17, 7, 60, 2 and 2. So these are all the arithmetic operators we have. Now let's go for the relational operators. Relational operators. So most probably relational operators are used for comparing two values. Okay, so as usual we'll take a program, we'll explain this in detail. Import java.util.start class main. As usual, the execution starts from the main method. Public static void main string args. Okay, so here I'll take two variables, int a equal to 10 and b equal to 5. I'll print system.out.println. So first I'm going to give equal to operator, which is used to compare two values, a equal to b. So here it will compare a and b. So whether 10 and 5 are equal? No, it is not equal. It returns the boolean value. It is not equal. So it gives the output value as false. Next, we have seen equal. I have to check whether it is not equal to or not. How can I check whether it is not equal to or not? A not equal to b. This we call it as not equal. So it returns true because a and b are not equal. It returns true. Next, system.out.println a greater than b. So I have to check whether the value of a is greater than b. 10 greater than 5. Yes, 10 is greater than 5. So I'll get the output value as true because a relational operator always gives the output value in boolean data type. Next, system.out.println a less than b. I have to check whether a is less than b. So here condition is false because a is not less than b because 10 is not less than 5. So condition is false. So I'll get the output value as false. Next operator is system.out.println a greater than or equal to b. I have to check whether a is greater than or equal to b. So 10 is greater than 5. So condition is true. So it gives the output value as true. Similarly, I'll check system.out.println a less than or equal to b. So here condition is false because 10 is not less than 5 or equal to 5. So condition is false and the output value is also false. That's all. Let's run the code now. See, false, true, true, false, true, false. That's all. Okay, so we have seen arithmetic operators and relational operators. Now let's go for unary operators. Okay, let me take the program import java.util.star class main. As usual, the execution starts from the main method, public static void main string args. Fine. I'll take a variable as a and I'm going to give the value as 5. Okay. First unary operator I'll go with system.out.println. I'll give plus 5. So here whatever be the value I have, it will convert into a positive value. Okay. So here the value of a is 5, so it gives 5. Now system.out.println minus a. So it converts negative value to positive and positive value to negative. So a is positive, so it converts to negative, that is minus 5. Then system.out.println we have plus a. See, when I say plus a, this we call it as pre-increment. When I say pre-increment, first it increments the value and then it gives to the variable a. So the value of a is 5. So when I increment, it becomes 6. Next, let's go for post increment. System.out.println a plus plus. So here the value of a will be printed as 6, but after printing the value becomes 7, because after this statement the value of a has been updated to 6. Okay. Now when I try to print a plus plus, what is the value of a? 6. 6 will be returned first. After returning, it increments the value to 7. Now if you want to know whether the post increment is once after returning the value has to be incremented, right? Whether the value has been incremented or not. To know that, I can give the value of a and check. Now I will have the value as 7. Let me run the code so that you'll have a clear understanding. See here, 5 minus 5, 6, 6, 7. Here the value of a is 5, so plus 5, positive value. The value of a is 5, minus 5, so negation, it gives minus 5. Then plus a, pre-increment, the value of a is 5, first increment it becomes 6, then print it. I have got 6. Now post increment, when I say post increment, what happened? First return the value of a is 6, that has been returned. After returning, it will increment the value. So it will increment to 7, but it will return the value first, that is 6. So 6 has been printed. After returning, the value of a will be incremented by 1, which becomes 7. So to know whether the value has been incremented or not, I am trying to print the value of a alone and checking here so that I have got the value as 7. Now let's go for decrement operator as well. System.out.println. So when I say pre-decrement, what happens now? It will first decrement. The value of a is 7. It decrements by 1, which becomes 6. Here the increment or decrement is done by 1. Okay. So 7 pre-decrement. So decrement by 1, it becomes 6 and then it prints the value as 6. Similarly, I'll go for post decrement. Println a minus minus. So the value of a is 6, that 6 will be printed. After printing, it is decremented by 1, it becomes 5. In the buffer memory, I'll have the value as 5. Now once the statement execution got over, the value of a becomes 5. Now let me print the value of a to know whether the decrement has been done or not. It will give us 5. Let me save the code and let me run the code. See, 5 minus 5, 6, 6, 7, 6, 6, 5. That's all. This is what called as unary operators. Next, let's go for assignment operator. Okay, so execution always starts from the main method. Before that, I have to import the packages. Import java.util.star. The execution always starts from the main method, before which we have to give the class name. Then main method, public static void main string args. Fine. Let me take a variable called a is equal to 5. Fine. Now I'm going to assign the value, right? So here the value 5 has been assigned to the variable a. So this is what called as assignment operator. Single equal to is called assignment operator. Double equal to is called comparison operator. So here, whenever we are talking about assignment operator, the right hand side value will be assigned to the left hand side. The value 5 will be assigned to the variable a. Fine. Now let me give other assignment operators. System.out.println. So here I am going to give a plus equal to 5. Let me run the code. See, I have got 10. How am I getting it as 10? It's very simple. So a is equal to a plus 5. This is the meaning. I am writing in the short form. A plus equal to 5 in the sense a equal to a plus 5. Similarly, system.out.println a minus equal to 5. What is the meaning here? A equal to a minus 5. So in this case, I'll have the output value as 10 because a value is 5. 10 plus 5, 15 will be, so 15 I have got, right hand side value will be stored to the variable a, that is 10. Now when I give a equal to a minus 5, so a value is 10, 10 minus 5, the value is 5, that will be stored in a variable called a, so I'll get the output value as 5. Similarly, we can use it for other operators as well. System.out.println a star equal to 5. Here what happens? A equal to a into 5. So here the a value is 5, 5 into 5, 25 will be the output value, that will be stored in the variable called a. Then division, system.out.println a slash equal to 5. So here what happens? A equal to a divided by 5. So 25 divided by 5, the quotient value is 5. So I'll get the value 5, that will be stored in the variable called a. Then I'll go for modulus, system.out.println a modulus equal to 5. So here a equal to a modulus 5. So a value is 5, 5 modulus 5, the remainder is 0. So I'll get the output value is 0. That's all. Let me save the code and run the code here. See, 10, 5, 25, 5, 0. We have got the output value. Now let's go for the bitwise operators. This is one most important thing we have to know. So as usual, we'll start with the program. Import java.util.star class main public static void main string args. Okay, I'll take a variable int a equal to 5, b equal to 3. I'll take these two variables. So before going to bitwise operators, we have to know truth table. So here 0 0, I'll take the input value 0 0 0 1 1 0 1 1. So when I say truth tables, here you have to know about and, or, XOR. So we have to know these three values. So according to AND gate, if any one of the input is false, it is false only. So 0 0 0, 0 states false, 1 states true. So 0 and 0, it is 0. 0 and 1, it is 0. 1 and 0, it is still 0 because if any one of the input is false, it's false only. 1 and 1, it is true. When I go for OR, if any one of the input is true, it is true. So here 0 and 0, both are false, so I'll get false. Here any one of the input 0 or 1, so 1, so I'll have true. 1 or 0, it is true, 1. 1 or 1, it is always 1. Similarly, when I go for XOR, if both the inputs are same, it is false. If both the inputs are different, it is true. See, 1 XOR 1, both are same, so it is 0. That's all. So this is the major thing which we have to know about bitwise operators. So I'll comment this. Okay, so a equal to 5, b equal to 3. First I'm going to give system.out.println a and b. So when I say and, we have to perform bitwise AND operation. So bitwise, so the value of a is 5 and the value of b is equal to 3. So here we have to take the binary value of a. So what is the binary value of a? For 5, the binary value is 0 1 0 1. Okay, now we have to go for binary value of 3. What is the binary value of 3? 0 0 1 1. Now I have to perform bitwise operation for each and every bit. So for AND I have to find the bitwise operation. 1 and 1. So it is true. So I'll have 1. Then I'll go for this one. 0 and 1. It is 0. 1 and 0, it is 0. 0 and 0, it is 0. So this will be converted as a decimal number and it will print it as an output value. So the decimal value is 1. So 1 will be printed as the output value. Similarly, when you go for bitwise OR, A or B. So let's take the same input value. Okay. A and B. So here what should I do? I have to perform bitwise OR. So when I have to perform bitwise OR, 1 or 1, it is 1. 0 or 1, it is 1. 1 or 0, it is 1. 0 or 0, it is 0. Now this will be converted as a decimal number. So the output value will be, this is 1, 2, 4. So 7. 7 will be the output value. Let me save the code and run the code. See, 1 and 7. Got it. Now let's go for XOR. System.out.println A XOR B. Let's take the same input values. Okay. So 1 XOR 1, it is 0 because inputs are same. Here inputs are different, it is 1. So here the inputs are different, 1. The inputs are same, it is 0. So here the decimal value is 6. So I will get the output value as 6. So this is the bitwise operators. Along with this, we have one more operator called left shift and right shift. Shift operators. Okay, so that we have two types, that is right shift and left shift. That we'll discuss now. System.out.println A left shift 2. Okay, let's discuss this. What is the binary value of 5? The binary value of 5 is 0, 1, 0, 1. This is the binary value of 5. Okay, here the integer is of 4 bytes, so we'll have 32 bits. But I have taken only last 4 bits. As of now, I'll consider for 8 bits for our easy understanding. So this is the binary value of 5. Now I have given A left shift of B, which means I have to move all the bits towards my left side 2 times. We have got the binary value of A as 5. So we have taken 8 bits. So when I say left shift of 2, each and every bit has to be moved 2 times towards the left side. So first it will be moved 1 times. This 0 will be removed. So this 0 will be moved to this place. So it is 0. This 0 will be moved to this place. So it is 0. This 0 will be moved to this place. So it is 0. This 0 will be moved to this place. So 0. This 1 will be moved to this place. Yes. This 0 will be moved to this place. Done. This 1 will be moved to this place. Done. Now the last space is empty. Here we have to fill it with 0. So I have done one shift. Then I have to go for second shift because left shift of 2 times. Now this 0 will be removed. This 0 will be moved to this place. Done. This 0 will be moved to this place. Done. This 0 will be moved to this place. Done. This 1 will be moved to this place. Done. This 0 will be moved to this place. Done. This 1 will be moved to this place. Yes, done. This 0 will be moved to this place. Done. So last place is empty. I have to fill it with 0. So this is the A left shift of 2 times the value. So now when I see the decimal value, so it is like 1, 2, 4, 8, 16. 16 plus 4, 20. So 20 is the decimal value. So here I will have the output value as 20. Let me run the code. 17620. I have got it. Okay. So in short, you can say whenever you are performing left shift operation, the value is multiplied by 2. You can remember it this way. See, A value is 5. So how many times I am doing left shift? 2 times. So 2 times you have to multiply. 5 into 2, it is equal to 10. 10 into 2, it is 20. In short form, you can remember this. Now let's discuss about right shift operation. A right shift of 2. So here the value of A is 5. So we are going to perform right shift operation for the value called 5. So here the binary value of 5 is this. Okay. So here 2 times I have to perform right shift operation. So here first this 1 will be removed. So when this 1 is removed, this 0 will be replaced by this place. So I'll have 0 here. Now what happened? This 1 will be moved to this place. Similarly, this 0 will be moved to this place. Next, this 0 will be moved to this place. Then this 0 will be moved to this place. Then this 0 will be moved to this place. Then this 0 will be moved to this place. Then here I have an empty space that will be filled with 0. I have performed right shift operation for 1 times. Now I have to perform for 2 times because a right shift of 2. The value of a is 5 that we have given here. So here you may think the value will get updated. No, the value will not get updated. Like assignment operator, the value will not get updated. Whatever the value of a, that will be taken and the operation will be performed. So here one more time I have to perform right shift operation. This 0 will be removed. So this 1 will be moved to last place. Okay. Now this 0 will be moved to this place. Fine. Next this 0 will be moved to this place. Then this 0 will be moved to this place. Now this 0 will be moved to this place. Now this 0 will be moved to this place. Now this 0 will be moved to this place. Now I'll have an empty space. So this I'll be filling it with 0. That's all. So 2 times I have performed right shift operation. The value is 1. So 1 will be printed as the output value. In short, you can remember whenever I'm going for right shift operation, the value is divided by 2. 5 divided by 2, my quotient value is 2. 2 divided by 2, my quotient value is 1. So I'll get the output value as 1. Let's run the code. See 17621. That's all. So in short, you can remember whenever you perform left shift operation, the value is multiplied by 2. Whenever you perform right shift operation, the value is divided by 2. Why? Because these are all the power values of 2. That is why we are dividing it by 2 and multiplying it by 2. That's all. Now let's discuss about the logical operators. So as usual, we'll take import java.util.star class main public static void main string args. Fine. So here I'm going to take int a is equal to 10 and b is equal to 5. So here it checks the condition and it is going to return me either true or false. So it is going to check the condition. For example, system dot, I'll take one variable and I'll give in system dot out dot println. So here I'm going to check a greater than b and b less than 2. So which means I am checking whether a is greater than b. So 10 is greater than 5, condition is true. So condition is true. So I'll go for second condition and logical and. It is not going to go for bitwise. Bitwise is different, this is different. So I'm going to check the condition. A greater than b, condition is true, and b less than 2, 5 less than 2, condition false. So here it is true, here it is false. True and false. What is the output I have to get? False. This is how bitwise operator works. Okay. Now when I go for cut, this is how logical and works. Now let's go for logical OR. System.out.println. The same value I'll give. A greater than 5, logical OR, B less than 2. So here the value of A is 10. 10 greater than 5, yes, condition is true. Or B less than 2. 5 less than 2, condition is false. True or false? It is true. See, according to logical AND, if the first condition is false, it will not check the second condition, because according to AND, both the condition has to be true to get the value. Similarly, when I go for logical OR, if the first condition is true, it will not check the second condition, because out of 2, if any one is true, obviously I will get my answer. With the help of the first condition, we can come to the final result for some cases. At that point of time, it will not check the second condition. So here, A greater than B condition is true. Obviously, I am going to get my final result as true. It will not check my second case. In this case, A greater than B condition is true, Based on the second condition only, I have to get my final result, because if it is true, I'll get true. If it is false, I'll get false. So I'll check the second case. This is difference between logical and logical OR. And we have one more thing called logical NOT. System.out.println not of a greater than 5. So first I'll check whether a is greater than 5. Condition is true. 10 greater than 5, condition is true. When I give not, it will take it as false. In case if the condition was false and if I am giving not, it is converted to true. This is the logic difference. Let's run the code now. See, false, true, false. This is what we call it as logical operators. Okay, that's all.